Welcome to another Ocean Ideas Talk, brought to you by ocean lovers.
I am delighted to welcome 4 leaders in this field to this panel session. This is your chance to find out about this exciting world-first approach to seascape restoration. Project Restore focuses not only on individual habitats, but also on fostering connections between habitats. I am delighted that we're joined today by Melanie Bishop. Melanie is co-founder of the Living Seawalls Project program at the Sydney Institute of Marine Science, or SIMS, and a professor of marine ecology at Macquarie University with over 20 years of experience researching ecological impacts of coastal cities and innovating solutions to mitigate these. We also have Ziggy Marzinelli as a marine scientist and associate professor at the University of Sydney, where he leads a marine ecology and microbiology research group, focusing on understanding the processes that generate, maintain, and impact marine ecosystems. We also have Mitchell Brennan, a PhD candidate at the University of Technology, Sydney, and SIMS as well, focusing on the conservation of threatened marine fishes and habitats, and leading the Sydney Seahorse Project, which aims to develop the conservation methodologies for the endangered white seahorse. And last, and of course not least, we have Paco Martinez-Baena, the Research Associate and Project Manager at the Sydney Institute of Marine Science. Currently, Paco leads the one-of-a-kind Project Restore, where he is pursuing his passion of restoring seascapes. And as a marine ecologist and restoration practitioner, Paco believes that we can bring back degraded ecosystems from the brink of extinction. Would you join me in welcoming our panel? I think first it would probably be good to go sort of from end to end to tell us a bit about what you do, about your role in Project Restore, about your work, and about how it all fits together.
Cool, thank you. So my name is Mitchell, and in Project Restore, I'm a research assistant, so assisting in conducting the field work and implementing the restoration activities. My primary focus is on the fish habitat enhancements, or the fish pods, and these are artificial reef units that are installed to promote fish biodiversity and abundances.
Thank you. Melanie.
So I'm Melanie. I'm one of the chief investigators, and my particular interest is the Living Seawalls panels. And so we have 4 habitat interventions that we are coupling and coordinating for the Project Restore. Kelp restoration, seagrass restoration, fish pods, and living seawalls. I'm really overseeing the living seawalls component, selection of sites, how we integrate it with the other rehabilitation actions. And so with living seawalls, I guess the issue we're addressing is that 50% of the shoreline of Sydney Harbour has been hardened and modified by built structures. These are vertical, these are smooth. If you've been out along the coast here and walked on the rock platform at low tide, you know that where all the life is in the rock pools, the nooks and the crannies. And so with our hardened and modified foreshores along Sydney Harbour, they're just not providing those protective spaces. So with the Living Seawalls panels, what we're doing is adding back those nooks and crannies to built structures to benefit marine life.
I have a million questions, but let's hear from Ziggy first.
I'm Ziggy. I'm also a chief investigator in the project, and I oversee the kelp and a little bit of the seagrass restoration component of that multi-habitat restoration that Mel was talking about. And there what we're trying to do is increase connectivity between these habitats, and specifically for seagrasses, trying to bring back those marine systems in areas where we have destroyed them. For example, those moorings where boats moor and on, the chain that drags around the seafloor and destroys seagrasses. We're trying to replace those moorings, which were called environmentally friendly moorings, and then replant those seagrasses back onto those places.
Thank you. Paco, tell us about your role.
Sure. Hi, everyone. First off, obviously, welcome here, and thanks for coming. My name is Paco. I am the project lead of Project Restore, and my role is integrating everything together and making sure that the delivery of the project is successful in a way that is scientifically proven, but also in a way that we can actually make it happen. So liaising with all of the public agencies that take part on this big project, making sure that we have the permits, and making sure that the science is also there.
Thank you. Now, I have a million questions, and I'm just going to pepper you with one or two, and then we'll turn to the audience so that you can find out your answers as well. Melanie, I'm going to start with you. I think probably a lot of people in the audience know the living seawalls or have seen images of them, but what are they made of? What do they help restore? How are they subtly different? Because I know all the panels look slightly different.
Yeah, so I guess think of a bathroom tile on steroids. So the panels themselves are about 50 centimetres in diameter. They're made of eco-blend concrete, including blast furnace slag and fly ash waste products from industry. And what they're doing essentially is adding back these missing habitats from built structures. So we have to date 11 different panel designs, and these are mimicking features of nature. So some of them have artificial rock pools in their surfaces that are designed to hold water at low tide when the water drains. Others have little indentations like crevices that provide moist and shaded environments for species. Others are modelled more on some of the natural features of our habitat-forming species. So the root structure of kelps, the complex geometries of shellfish reefs, sponge fingers. And so what we've found is that when we provide these complex geometries on built structures, we're getting up to 3 times the number of species as a flat and featureless surface of similar age. And what we're also finding is that, as the climate warms, we're providing really important protective habitat from heat stress. So in the rock pools, for example, there's temperatures that are 10 degrees Celsius cooler than the flat surfaces of the panels. And each of our panel designs is just supporting a distinct biodiversity. So different things are coming to live on our different types of panel.
Bathroom tiles on steroids. Stop, Professor, you are confusing me. Mitchell, I'd love to hear a bit more about the white seahorse and your work in particular with that. Like, how are we seeing populations returning? What are the changes we're seeing?
Yeah, so the white seahorse is an endangered species of seahorse endemic to the east coast of Australia. And we've seen huge population declines in the last 10 years, so upwards of 95% in some areas like Port Stephens. So huge losses of the seahorses. And this is primarily due to habitat loss. So in amongst Project Resource, some of these key habitats like the restoration of macroalgae and Posidonia australis as a seagrass, these are critically important habitats for the seahorses. So within the confines of Project Restore, we're enabling the habitat restoration of these natural habitats, but we're also installing some artificial habitats called seahorse hotels, which supplements this habitat restoration and enables us to then breed and rear seahorses in the captive environment and release them out into the wild to boost populations.
So how are they returning? How are those populations being boosted?
Yeah, it's been really positive so far. So we released 400 seahorses into Chowder Bay in Mossman last year, and we've been monitoring those for going on 9 months now. And every single dive, we're recapturing over 50 of those seahorses on a single dive. And actually, the last dive that I did in February, we had 20 pregnant captive bred seahorses out in the wild. So these are now contributing to these wild seahorse populations.
Forgive what, it's not meant to be a stupid question. Can you tag seahorses? Like, can you track where they go?
So tracking, not so much. So we can tag them, but for lack of better words, it's a tattoo injected under the skin, so subcutaneously, and we have to go out and recapture them. Seahorses, even at fully grown, are only about 8 grams, so a satellite tracker is just out of the question, really. So we tag them and then go out. Fortunately, they don't move very far. These guys have a maximum home range of about 100 metres. So we can go out and recapture them, and using the tags, we can see the individuals and monitor how they're progressing in the wild.
So you can't put 360 onto their smartphones, you just have to inject under the skin.
Yeah, exactly. That'd be the ideal scenario.
Ziggy, I know last year at the Ocean Lovers Talks we had a session called I Get By With a Little Kelp From My Friends, which was my favourite dad joke of the whole season. Can you tell us why the kelp is being so threatened? You've mentioned a couple of different things. Why is the kelp at risk?
So I guess the main threat for a lot of these things, not just kelp, is ocean temperatures increasing. Mm-hmm. So that's one big sort of impact on these habitats. But then associated with that, there are other things that relate to changes in climate and so on. For example, increases in the intensity and frequency of storm events. You get massive rainfall like what we got a couple of years ago, that the Harbour was brown essentially for a long time. So all those changes in water quality, salinity, and so on affect these populations. And then there's also changes to ecological interactions. So things that feed on other things are changing as well. So it's it's a combination of all those sort of like direct impacts from all these stressors, as well as how interactions between marine organisms are changing in response to that. So in the context of kelps, I guess a good example, and that goes back to that session last year, is another species that we've been restoring along the Sydney coastline for the last 15 years or so, which is crayweed, which is another really important marine habitat that disappeared from the Sydney coastline, and that is really strongly linked to, at the time, sewage pollution. So the water quality here in Bondi, for example, was not nice. And many people in the audience that lived here for a while would know that. But then that was fixed in the early 90s. But what we're seeing in marine systems, and generally in any ecosystem on the planet, is that sometimes, even if you remove the cause of degradation, systems don't come back on their own. And that's where we have to sort of like intervene, essentially. And that project has been great. And again, the cause was poor water quality, generally speaking. But now we are thinking into how can we restore these systems, all these habitats, into the future. So for example, how can we reduce temperature effects by being clever about how we modify these habitats and so on? Can we actually use certain populations that we know are more tolerant to warming, for instance, and use those to restore, or at least increase the diversity of those populations by adding some of those into the system and so on? So the solution really has to be not for now, but also thinking into the future.
You mentioned different interactions between marine species. How are those changing?
So we're seeing, for instance, in the context of, again, ocean warming and the intensification of the East Australia current. If you watch Nemo, all the kids here probably watched that movie once. That's actually has been happening for a while. So we're seeing a lot of tropical species coming into temperate systems. In the past, they would only be here throughout the summer, and then once the water temperatures would get colder, they would die, for instance. But now we're seeing that they're starting to, survive and establish and start reproducing in these systems and so on. So some of those species, for example, are herbivores, herbivorous fish that are starting to come further south. And then those guys have a lot of food here because most of the main sort of like underwater habitats are, for example, kelps or seaweeds. And these guys come from coral reefs where seaweeds are not that abundant. They come here, they encounter that. If they like it, that's a big problem potentially, because if those numbers of fish keep increasing, then probably those kelp forests are going to decline.
Gotcha. All right, Paco, how do we bring this all together? Because there are some amazing work, amazing different projects going on with kelp, with the fish pods and the seahorse hotels. How do we bring it all together?
Exactly. So what we're trying to do here, and what Project Restore is aiming for, is we know that we have amazing research and amazing restoration initiatives in Sydney, made by the four major universities in Sydney and the Sydney Institute of Marine Science. We know that these initiatives work, and they've been really successful in what they're doing. So the whole process is, okay, we know that these work, we know that we can do restoration, we know that we can bring back those habitats one by one. What happens if we bring them all together? And that's the whole concept of seascape restoration. Seascape restoration is being increasingly trendy worldwide as a way of, when you see the ecosystem in general, and you see, let's say you see Sydney Harbour as a natural setup, and let's take out the 6 million people that live in Sydney, and let's take out the whole city, you will find that the natural habitat of Sydney Harbour will be a continuum of habitats from Parramatta to the heads, and also from intertidal to subtidal. You'll have mangroves and salt marsh on the upper river, and then you get that rocky reef, and then you ended up in the heads where crayweed, for example, exists. And so what we're trying to do here is, okay, how can we restore the whole thing at once? And how can we make sure that those habitats are connected so they also can help themselves protect each other? We know that when you put some habitat next to another habitat, they interact. And the scale of interaction depends on the size of the patch and the amount of the health of the patch as well. So how can we use that to increase the resilience of marine habitats, looking into the future, as he was saying, but also for the purpose of restoration? And that's what we're trying to do with Project Restore, combining these four methodologies: kelp reforestation, seagrass restoration, living seagrass installation, and fish pod deployment, to increase the overall complexity of the system, bring back those biodiversity that we've lost, and also make sure that our habitats are more resilient.
How do you measure these interactions between all the projects?
Yes. So obviously we need really strong monitoring protocols for this to happen. I guess for Project Restore we have 5 major goals where we're trying to achieve and measure success against. The first one will be we want to ensure that the populations that we're restoring are healthy, are in a good condition, and that they're properly restored. That condition and that success is different from each habitat. For example, for Posidonia, we need to achieve a certain density of shoots that we're replanting, and that those shoots, the survival of those shoots are ensured. For kelp, it's a different thing. It will be like the density of kelp will differ from seagrass. So we need to make sure that we apply that success to every single habitat. And then across the seascape, what we're trying to do here is also make sure that we also measure how fish move from habitat to habitat. If we see an increase of the movements of fish, for example, within those two habitats, that means that we're getting success. That means that we're getting those highway between those habitats connected again. Similarly for nutrients, similarly for sediments. So we make sure that we measure everything from a habitat scale, but also from the seascape scale.
I'm going to squeak in one more question, and then I'm going to come to the audience for yours. How is this all funded? This sounds like a massive undertaking.
Yes, and restoration is not cheap and is really hard. So we're lucky that we have been supported by the environmental trusts. It's a major funding body for Project Restore so far. And then is a bigger, so we're part of a bigger program called Seabirds to Seascapes. The funding, again, comes from the environmental trust, and then we're partnered with the Department of Planning. Now they changed the name to the Department of Climate Change, is DQ, and then also the Sims and Taronga Zoo. So there's 3 major projects within this program. One is us, we're the biggest one, Project Restore, and there's another one looking at the penguin colony census and an seal colony census in partnership with EPE and Taronga Zoo.
Wow. All right, questions. I think this is the only spare microphone, so I'm going to be running around the room. Questions from the room. I'll come over here first. All right.
Thanks. My question's for Professor Bishop. Have you found any differences in temperature with the natural substrate versus your tiles? So you said obviously with the flat tiles you had a 10-degree difference. With the natural substrate, is there any?
Yeah, so we are putting loggers out as we speak that are also in natural rock pools and crevices. So it will be really interesting to see how our artificial rock pools and crevices are comparing to those. But yeah, I mean, there's a lot of variability, and so a lot of it depends on orientation and aspect. And so in Sydney Harbour, you know, we can have sites that are separated by 100 metres that can be 10 degrees Celsius difference in temperature just by the way they're facing, whether they get the afternoon sun or not. But certainly if we can be smart about the way we design our built structures, then, you know, we can give our critters a better chance against the warming climate.
Thank you. There's another question here. I'll pass the microphone up.
I just heard there was green coral growing at De Broy Point and Deadman's. Is that something new, or has it always been the case? Is it because of climate change?
That's a very good question. We actually have a PhD student at Sydney Uni with Will Figuera, who is a scientist there, trying to understand what is leading to how those colonies are expanding and so on. And long story short, it seems that they had been here before, but it may be that they are coming back and expanding because of these changes we're seeing. But it seems to be something that is endemic, that was always here based on records in the Australian Museum from the 50s. Yeah.
This is a question for all of you, and it's an opinion question. So let's say if we dealt with all the stormwater entering the rivers and the septic overflow, how long would it take the harbour to bounce back?
Very good. Whoops. Yeah. I think that's a very good question. If we use the example of the outfalls here, so when I was talking about that problem with water quality, so the government basically improved the treatment of sewage and then decommissioned the ones on the shore basically and built the new ones that are 5 km offshore. And there's one off this coast here. If you look at the reports from the government monitoring water quality and so on, showed a massive improvement really quickly. So I think it was within, I don't want to, don't trust me on this one, but a couple of years. So it was really, really quick, and water quality improved really quickly. So, depends on how you do that. The problem and water quality is really one of the reasons why we are excited about this project is because we can do these things because we know that the conditions are now suitable to do these kind of things. If we were to do this in the 80s, that wouldn't work, right? So it's pretty good, but how can we make it better? I guess the question is, yeah, absolutely. I think water quality is one of the biggest issues, and it may not be sewage the problem now, although when you have these big storm events, which are going to become more frequent and intense, that's going to be a problem, those overflows and so on. So absolutely.
Can I just add to that? So I guess to get healthy habitats, we really need three things, right? So we need a suitable environment. I guess adequate environmental quality in terms of water quality and the likes. We need a suitable substrate, so something suitable for them to grow on or in. And then we also need a source of larvae or juveniles or propagules to kickstart the whole thing. And so, I think what we're getting to in Sydney Harbour is that we do have the water quality, we do have the environmental conditions now that will support these species, but in some times, what we're having to do is give them a helping hand in terms of the right substrate or material to grow on, and in some cases also seeding, so providing either adults that are reproducing to kickstart the population or juveniles that can grow up where there isn't a natural source.
And I guess to build on that, provide an example. For example, Posidonia australe is an endangered species under the EPVC Act. In Sydney Harbour, we've lost pretty much 90 to 95% of it. There's only a few small patches here and there. The conditions have improved, but that doesn't mean that the habitat itself have improved, because it's a very slow-growing species, because, for example, in the New South Wales coast, we found that it doesn't seed, it's just duplicating, so it's very slow. So when Mel was referring in giving a helping hand, that means that some species will find that by just mitigating the impacts that were limiting the recovery, you'll get that habitat back. In some others, they need the active restoration to happen. Another example, if the Angasi native flat oyster is functionally extinct in the harbour, and there were massive shellfish reefs subtidally of these species that now they're completely gone. So if we want to bring that back, we actually have to have that active restoration that will support, the decreasing in water quality and so on.
And how about the seahorse habitats as well? Is this a 5-year, a 10-year, a 50-year project before we see these populations come back?
Yeah, so it is potentially going to be a bit longer term. So the seahorse hotels, as well as the fish pods, are artificial habitats that provide a pretty quick fix. Where it enables us to sort of mitigate the issue on a shorter time frame. So seahorses will start aggregating on some of these things in 2 to 3 months, but they have a sort of long-term lifespan as well. So we need to continue the habitat restoration as well, so the reintroduction of these Posidonia australis, of some of these algae and sponges and things as well, which is more of the long-term process, and that's what will allow seahorses to recover, but many of the fish in the harbour as well will start reproducing on a better level. For the fish pods in particular, a lot of juvenile fish will start using the fish pods as they begin to have more of this growth on the fish pods themselves, and they'll be able to hide from predators essentially, they'll be able to protect themselves, and then that will start proliferating as they expand and start repopulating more of the harbour as well.
We've got time for 1 or 2 more questions. Let me go down to Paula first, and then I'll come over to you.
Thank you. Obviously all very exciting and important work, but when you think of Sydney Harbour, there are so many stakeholders and so many different interest groups surrounding that harbour that actually impact the environment in which you're working. Can you tell us a little bit more about how you're addressing that? Because I would have thought that if that level is not addressed, then the issues will keep on repeating. Thank you.
That's an amazing question, thank you. It's really important, and it's actually, we cannot do restoration with the support and assistance of the community and all the stakeholders that use the space. So actually, one of the first things that we are really excited about Project Restore is we're integrating and we're collaborating with social scientists who are developing for us, for the first time, a socio-economic monitoring protocol that will be able to be implemented in restoration projects such as this, to be able to measure that change in perception, that change in behavior from the community. And that's really important for us to assess the success of the restoration in the long term, because obviously we're here, the funding of restoration usually goes for 3 to 4 years a maximum. And then once the habitats are there, the community are the ones in charge of the stewardship of the place. And so that engagement with the locals and that engagement with not only the local community, but also the local agencies and the state and federal agencies is key for the long-term success of that. So obviously first we have a different engagement for different agencies. We're working a lot with councils, for example, that are present in our restoration areas, but also with the state public agencies such as Transport for New South Wales, the Department of Primary Industries, and the Department of Planning, who integrating all of them together can help us assess that long-term sustainability of the area. Obviously, for Posidonia, for example, one of the major causes of decline, as Ziggy was saying, is moorings, and those swing moorings. In areas where Posidonia australis should recover, now we have a mooring field. And so with those moorings, what happens is that the chain drags into the sediment, as Ziggy was explaining, not letting not only the Posidonia to recover, but also not letting us to restore in those places. We currently have funding to replace 16 moorings with environmentally friendly moorings. Those mooring owners that have a boat and have a mooring can come to us. We can do that replacement. The environmentally friendly mooring works the same, but that will allow us restoring Posidonia underneath because the chain is neutrally buoyant. So one, we're interacting with the causes of decline in Sydney Harbour by interacting with those mooring owners. And two, also, the boating community is also key in the restoration and protection of Posidonia in this sense. The propellers can cut a lot of the Posidonia meadows in a minute. Things that grow in decades can be completely gone in seconds by those boat propellers. So making sure that the community doesn't anchor on those Posidonia fields or those upcoming Posidonia fields, hopefully with the assistance of us, and making sure that that knowledge is passed. Sometimes I always feel, and we all agree here, that the community is keen and is keen for restoration, is keen to get Sydney Harbour to be a better place. They just need the tools and the knowledge for them to steward that. And so hopefully with this monitoring protocol, with all of this engagement that we're trying to do here, we hope that in the future we will be able to consider that and make sure that they protect the habitats that we're restoring as much as we do.
This question's for Melanie. I imagine as you guys are putting out the living seawall tiles that you get a lot of different species settling on them, and that would be a pretty cool opportunity to study competition. Are you guys studying competition, and have you found anything cool?
Yeah, so I guess, the benefits of the panels can arise through a number of different ways. And so not only are they adding these protective spaces and these missing microhabitats, but the other thing they're actually doing is increasing the surface area of hard substrate for things to attach to. And so you're quite right. I mean, competition for space is a key factor, shaping communities on these hard substrates. And one of the problems with built structures is they're vertical, they're smooth, they don't have much surface area. And so growth really gets compressed into this really narrow zone, and it's intense. Competition is intense. And so I guess what we're doing is essentially tripling the surface area for things to grow on. So the backs and fronts of panels, the existing seawall in some instances, and then, the three-dimensional geometry. We are seeing really different communities, both as a function of the protective space, but also changes to competitive interactions as well.
We need to wrap things up now, but last question. How do we all support Project Restore? What do we need to do to support your work?
I guess, so as I was saying, if you have a mooring, please let us know. We have that funding to replace that mooring for an environmentally friendly one. Two, we have two citizen science projects based in Pittwater and Bandina in the Hawkesbury, so that you guys can help us collect those Posidonia shoots that we need so much to do the restoration in Sydney Harbour. And then, just keep on doing the great job that you guys are doing by picking rabbits from the beach and engaging with us when you see us in the fields. And your support is, we see it, and we love when you guys just come up to us and ask questions. And I guess, tell the story as well. It's really important. So, and then obviously, we could have some further volunteering opportunities. Soon in this year, we'll need the support of fishermen that will help us collect some bream to tag them and make sure that they know where to go. Also, if there's some philanthropists in the room, philanthropists always helps. So there's plenty of ways that you guys can support, and you can always reach out to us in social media and website, and then we'll make sure that we get back to you.
Can I just add one thing? So this is really just the beginning. And so what we hope with this project is that it will be a template for seascape restoration projects to come. And so if you like what you're hearing, I guess the other thing you can do is get behind, your local members, your politicians, and, encourage them to invest more in this kind of project because, there is a lot of work to do and this is just the very start.
Would you join me in thanking Mitchell, Melanie, Ziggy, and Paco?
Thanks for tuning in. We hope you enjoyed this episode of Ocean Ideas. Please make sure to share it with your networks and help us in our mission to turn ripples of action into waves of change for our blue planet.